Hi, I wanted to put another homework video over the 11.2 questions again because many of you have not had to simplify radicals before. I wanted to just go through some more examples from the second part of the 11.2 assignment. So I'm just going to walk through some of these with you and try to keep this to 10 minutes or so. All right, so if you look at number 36 in your book, and this is on page 723, the directions are to simplify the expression. Well, from my first video, when you try to subtract radicals, you must have a like radical. And if you look here, I can't subtract square root of 6's and square root of 54's. So your first inclination might be I can't do anything here. Well, actually you can, because remember, the square root of 54 is a radical that is not simplified. There is a perfect square that goes into 54. And when I think about that, 9 times 6 is 54. So I still have 2 square root of 6 minus 5, but the square root of 54 can be broken into square root of 9, square root of 6. And then the square root of 9 is actually a perfect square. That is 3. So I have 2 square root of 6 minus 5 times 3 times the square root of 6. And now what I can do is take that 5 times 3, multiply that together, and get 15. I now have 2 square root of 6 minus 15 square root of 6. Now that I have a like radical, I can actually subtract those, and I end up with negative 13 square root of 6. In question 38, I'm trying to add these three radicals. Now, obviously, I can't. They're not alike. But are they all simplified? I know 3 is prime. I can't. There's no perfect square other than 1 that goes into 3. And 6, and there's no perfect square that goes into 6 other than 1, because 4 does not divide evenly into 6. But 12 does have a perfect square number that will go into it, 4. So I'm going to break this up into radical 4, radical 3, and I still have the plus 6 square root of 3 and the 2 square root of 6. And the square root of 4 is actually 2, so I have 2 square root of 3 plus 6 square root of 3 plus 2 square root of 6. And you notice now these do have a like radical, square root of 3. So I can add these. 2 square root of 3 plus 6 square root of 3 is 8 square root of 3. Plus I have the extra 2 square root of 6. I can't add these together. I do not have like radicals, and since I can't simplify those radicals anymore, I am done simplifying. There's nothing else I can do. Question 40. Again, I'm simplifying the expression. This is a distribution problem. I want to distribute the square root of 5 through the problem, so I do. Square root of 5 times 5 is 5 square root of 5. Remember, I can't somehow combine those together into 25. But the square root of 5 times negative square root 5, well, I do have a negative there because positive times negative is negative. But the square root of 5 times the square root of 5 does work out to square root 25. Now, I want to simplify if I can. Square root of 5 I can't simplify, but the square root of 25 I can. The square root of 25 is just 5. So I get 5 square root of 5 minus 5 as my simplified expression. 48. If you go to the next page, I'm now on page 724. They're still asking me to simplify these. Now remember, one of the first rules of radicals, or simplifying radicals, I should say, is you cannot have a fraction under a square root. So I know I'm going to have to get rid of the fraction under the square root. And I'm going to do that in just a minute, but the first thing I notice before I even worry about that, do you notice how 4 goes into itself once, and 4 goes into 600 150 times? Well, if I do that, I've just simplified this problem and made this a little bit easier for me to work on. Okay, so from there, I'm going to break this up into 2 separate radicals. I have radical 150a in the numerator, and I have the square root of b cubed in the denominator. Let me write that here first, okay? Now, let's think about this. I can't take the square root of b cubed, but I can break the square root of b cubed into b squared, square root of b squared, and the square root of b, because b squared times b is b cubed. So I'm going to do that. I'm going to break this up into the square root of b squared and the square root of b, because that combined is still the square root of b cubed. Okay, so now in the numerator, 150 is not, I misspoke there. 150 can be divided evenly by a perfect square. 150 can be divided by 25, and that is a perfect square. So I'm going to break 150 into square root 25, square root 6, and I still have the square root of a. And in the denominator, do you notice how the square root of b squared is just plain b, and I still have the square root of b? And I'm going to go on to the next page. I'm going to rewrite that out again. Okay. Everything here is working in the direction we want of simplifying. Remember, there's 3 rules to simplifying. You can't have a fraction under a square root. We've taken care of that. We cannot have a square root in the denominator, if you recall. That's another major rule of simplifying. I do have a square root in the denominator, so what I'm going to do is I'll multiply the numerator and the denominator by the square root of b. And the reason I'm doing that is, if you notice right here, the square root of b times the square root of b would give you the square root of b squared, and the square root of b squared is just plain b. So now I have square root of 25, square root of 6, square root of a, square root of b in the numerator, and I have b times b in the denominator. And now I don't have any square roots in the denominator either. And then there's only one thing left to do. The square root of 25 I can simplify to 5. So I have 5, and then all these are primes, so I can put them all back under the square root, 6ab. So I have 5 square root 6ab all over b times b is b squared. I just simplified that. In number 50, I want to add these fractions. I cannot add fractions that do not have a common denominator. So the first thing is to get a common denominator. Well, when I look at the square root of 12, this is not in simplest form. So I'm going to put the square root of 12 in simplest form to start. I know that the square root of 12 can be broken into square root of 4, square root of 3. And the square root of 4 is 2. So I end up with 4 over radical 3 plus 7 over 2 radical 3. Now, I did that for a reason. Do you notice how these both have radical 3 in the denominator now? So I'm very close to having a common denominator. They both have a radical 3, but this has a times 2 in it. This doesn't. Well, if I just take the first fraction now and multiply the numerator and the denominator by 2, and I'll do that again here. Let me write that down. If I multiply the numerator by 2 and the denominator by 2, I haven't heard anything. I multiplied each by 2. I now have 8 in the numerator for this first fraction. I have 2 radical 3 in the denominator, and I'm adding that to 7 over 2 radical 3. Now I do have a common denominator. I can actually add this. So 8 plus 7 is 15. And I have 2 radical 3 in the denominator. Now, there's one rule I'm still breaking if I keep it like this. Remember, you can never have radicals left in the denominator, and I do. So to get rid of that radical in the denominator, I'll quickly multiply the denominator by radical 3 and the numerator. And when I do that, I'll have 15 radical 3 in the numerator. In the denominator, I have 2 times, well, isn't radical 3 times radical 3 radical 9? And now I want you to think, what is radical 9? What is the square root of 9? Square root of 9 is 3. So now I have 15 radical 3 in the numerator, and I have 2 times 3 in the denominator. And here would be a common mistake. Some of us would just put this down and quit. But if you quit, you also forgot that I can divide 6 by 3 and get 2, and I can divide 15 by 3 and get 5. Your final simplified answer to this would be 5 radical 3 over 2. It is perfectly legal to have radicals in the numerator. Remember, I can't have them in the denominator. And I have one more example to quickly walk through. This video is close to 10 minutes here, so I don't want to make it too much longer. In numbers 55 to 62 in your homework, you need to use what's called conjugates to simplify this. And a conjugate means that we have in the denominator, we have a radical as part of a binomial. And to get rid of that radical in the binomial, a conjugate is when you add that exact same binomial, I misspoke. When you multiply, I meant to say that exact same binomial, but the difference is instead of it, you don't use the same sign. So the conjugate to 2 minus radical 3 would be to say I'm multiplying by 2 plus radical 3. But remember, if I do that in the denominator, I got to do it in the numerator. So what I'm doing here is called a conjugate. I'm multiplying by the same binomial, just different sign. All right? Now when I do that, I have to double distribute in the denominator. So I'm going to take 2 times 2, and that's 4. And I'll take 2 times radical 3, which is 2 radical 3. And I'll take negative radical 3 times positive 2, which is negative 2 radical 3. And I'll take negative radical 3 times positive radical 3, and that's negative radical 9. In the numerator, I would end up having to take, let me use a marker here, I would end up having to take 9 times this stuff. I just wrote it out like that right now. Now, here's why we do this, because there's a couple things you're going to notice. These cancel out. 2 radical 3 minus 2 radical 3. So that's why we use a conjugate. You notice the radicals are no longer in the denominator now. And I have 4 minus, radical 9 is 3, I have 4 minus 3 in the denominator. And in the numerator, I'll quickly distribute. I have 18 plus 9 radical 3. Well, I end up with 18 plus 9 radical 3 over 1. And that ends up being 18 plus 9 radical 3. And this satisfies all 3 rules of writing radicals. Remember, I cannot have a radical in the denominator. I got rid of that. I can't have any fractions under radicals. I don't. And any radicals that I have left must be in simplest form, which means, remember, there cannot be any perfect squares that would divide evenly other than 1 into this radical. Well, that's the only perfect square that would divide evenly into 3 is 1, so this is simplified.